So it's my pleasure to be here with you all this morning. Thank you for coming to the session. My name is Abigale Stangl, and I'm a PhD student at the University of Colorado. I'm working with my advisor, Dr. Tom Ye, who is a computer scientist. And so we're coming to this work from the field of human-computer interaction. And my training and orientation is from architecture and design, so I'm thinking about this work from a material perspective and an experiential perspective. Before I go further, I just want to acknowledge that our work involves a lot of people, both faculty members at the University of Colorado, graduate students, and undergraduate students. And so we're really trying to involve people at different levels of education in this project. I won't read off their names at this point. So in these short 20 minutes, I'm going to be presenting to you some of our community-based design activities, to be looking at how to broaden participation in the design of tactile materials that can be distributed through the use of 3D printing and other emergent technologies. And then, if I have time, I will talk about some of the more computational-based methods that we're looking at to improve 3D modeling through both augmentation of the hardware and the software to make the design process more accessible both to people with visual impairment, but also to novice 3D modelers and designers. So on this slide, there are a series of 3 images. One is of 2 hands and handmade materials. The next is an embossed tactile graphic of a house represented in a perspective orientation. And then the third is of a 3D printed model of a house as though you would be feeling the door, coming into the door, and a 3D printer. And so here, we're just creating an overview of these different modes in which we can, or the different materials that we can be thinking about designing, these materials that Philip had represented earlier. So our work began in 2013, where my advisor, as a computer scientist, he got really excited about 3D printing and how to think about the technical considerations in the digital media space. But as a designer and as a participatory designer, I was really invested in making sure that as they're thinking about working on designing these books, we really got involved with the community. And because we know of the low incident rate of blindness in our communities, we decided to use the affordances of 3D modeling, which meant that we could rapidly produce replications of the same image and send them out to different people. And our question at the beginning was, how can 3D printing facilitate the processes to get the content in the hands of children and support parents and teachers particularly? And so what we did is we sent out these cultural design probes. And in the HCI literature, this is really meant to be sparking investigation, moving beyond kind of the paradigms that we know for how to produce this material, and engaging community in a new way. So this is an example of one of our first designs. This is an image of a woman or a young girl touching a 3D printed page. It's an up-close image of the book Goodnight Moon, a classic American story. There's a house and a mouse. And so as we were sending out these, we got requests from different stakeholders, including different scholars, teachers of the visually impaired, Braille transcriptionists and designers, and then parents. And so we started to get some feedback and understand how the community was interested in using these materials. People wanted to display them as ways to promote 3D printers. People wanted to look at how to use them to inspire students to become involved in design. Teachers saw them as these models as a way to reduce their time in designing materials. So we were just starting to understand these community considerations of this material. And so from that, there's a diagram on this page which is more just about a thinking tool for us to start to identify what are the design opportunities within the computer science world to support the design of tactile materials. as many of us have probably thought about, a 3D model library specifically for STL files, stereolithography files for 3D printing, thinking about different communication devices so that teachers and parents can communicate their needs with designers, and how to think about embedding sensors into the models to solicit more of the auditory, to complement the books with auditory features. So we immediately got some press for this, which actually helped this effort to send out more design probes out into the community. And so since that initial effort, we've been, we have a website that we've put up where parents and teachers and other interested people can come and request a 3D printed book. And this is an effort on our lab's part to have impact in the community, also for us to respond to some technical questions that come up as we're trying to mass produce these books, or not mass produce, but produce them in one-off fashions, but also as a way for us to teach some of our younger students how to use a 3D printer, how to customize these books based off of parents' requests for their children, and kind of exploring what is the range of feasibility within this project. And so this is an image of our webpage where we're just asking people to send in their name and their contact information and any comments they want to provide for why they would want a book. And so we've, at this point, done about 28 books. And some of the variations that are represented in these images are us looking at different, some parents have asked for different binding options. And so there are 8 images. One is of a book that is bound just with 3-ring binder clips. Another image is of a binding that was hand sewn by one of our researchers. So sometimes I like to joke that I'm just doing arts and crafts research, which it's pretty fun. But the second row of images is of some of the hand-sewn tactile designs of a lion and a tiger. This is from the book Noah's Ark. One family requested this book for a birthday, and so forth. And then we can easily customize some of the 3D modeled features on these books as well. And so, for example, if a parent wanted their child to learn the word boat as opposed to the word ark, we could quickly go in and change that braille and print the braille differently for that child. And so this is a map of the world representing where we have gotten requests and sent out our books. Again, this is a design probe, and we know that these books need to be improved upon, but the best way is to get them into the hands of the parents and the children to receive that feedback. So now I'm going to move on to a slightly different project. Just quickly, because of these design probes, we have had some really interesting kind of collaborations all over the world. One was when a USAID worker in Indonesia learned of our project, and she was working in a school for the blind, as well as in a digital fabrication makerspace at a university. And she too had the idea of, well, why can't we use 3D printing for this task? And so she contacted us and asked us if we could make a book for her, or help us figure out how to support her and her students to make a book. And initially she was just thinking, oh, we'll take an image and we'll just raise it up and that's it. And so this was an opportunity for us to talk to her and share with her some of these design considerations that we heard about earlier in terms of really trying to make the content accessible and informative in a more semiotic communicative way. And so what we did is we worked with her to design an inclusive design experience where students from the local school would come together with the technology students and go through a series of activities. So on this slide, there's a picture of one of the young blind students using modeling clay, and there's a map of the globe with Indonesia indicated on that. This is a picture of the school and the community where this project was situated. We are doing this remotely, which again is the benefit of being able to work in this digital space and with digital medium, is that we can extend these conversations and share files that can be reproduced locally in both places around the world. So this is a slide just to demonstrate some of the collaborative processes at work. There's an image of the co-design process where some of the students with visual impairments were brainstorming. This is all based around an Indonesian folklore called mouse deer. And then essentially what happened is that they sent these pictures to us, and then our team, our undergraduate students who are learning to 3D model using a code-based modeling program, then modeled those. We have a river that was modeled, a deer mouse, which is essentially a deer that is very small, and then a palm tree in this vegetation. And the deer mouse story is kind of clever. It's about a mouse that tricks a bunch of alligators to line up across the river so he can escape them. I won't go into details, but so here I'm going to shift gears again. I'm really just trying to give you a smorgasbord of our lab's work so you can come and ask some more questions. But as we've been doing this, I've been working with teachers and librarians and parents, and recognizing one of the limiting factors is learning how to 3D model. As an architect or as a designer myself, I know that barrier to be very true. And so the questions were, how do these different stakeholder groups approach this design task using this new medium of 3D modeling as one possible way of producing these books? And so on this page we have images of several of the books. One image is of a polar bear and 2 cubs, and then the 3D modeled version of that, and then a bird flying, and a scattered model of that part. So we conducted a series of 6 workshops with different stakeholder groups. We led these with 4-hour sessions, and we used qualitative methods to kind of observe their design processes and their perspectives that they brought to the table while designing their books. And so this is a slide with images of some of the books that they chose to model from and what they were able to accomplish in the 4 hours. For the most part, none of these models were printable, in part due to the technical constraints of 3D modeling and printing. Essentially, if you have space between 2 objects, they need to be merged, because otherwise the 3D printer will not understand how to make the connection between those parts, and it'll kind of go crazy. But again, this was more of a design investigation as opposed to thinking about ending up with a really, truly accessible end product. So this is a series of diagrams on this image that are essentially showing the different stakeholder groups and their considerations and their kind of values and what interests they represented during this design work. And so we were focused on how they kind of were thinking about disability, literacy in general, project management, graphicacy, and then the actual modeling task. So those are some of the dimensions of the design process that we were starting to identify. And so from there we recognize that there are some requirements that are really part of this work. And again, we are doing this in the hopes of thinking about how to design different 3D modeling programs or collaborative design systems that would actually support collaboration between 3D modelers, teachers who don't have time to learn how to 3D model, parents who really know the needs and considerations of their children, as well as teachers. And so we recognize that there are 4 kind of activities. There's the needs assessment and the actual evaluation of the product, the need to select content from books that should be appropriately transcribed, considerations about the actual type of representation that occurs, and then again thinking about the production and making sure that is organized well. And so there are 3 main roles that we identified: the end user advocate, the task manager and then the modeler. And so thinking about how can we design systems that bring these people together in ways that they can become productive designers, specifically within the 3D modeling and printing environment. Okay, so I'm shifting gears one more time, and I have 5 minutes left. That's great. So as another kind of tangent of this work, we've been thinking about how to involve a broader group of students and people into thinking about this design task. And we've just been awarded a National Science Foundation grant in the United States. It's where a lot of our funding comes from and might be different soon, but the grant that we received is Innovation Technology Experiences for Students and Teachers. And as we've been exploring this, in the United States, and I'm sure in many other countries, there's a strong focus on the science, technology, engineering, and math learning. And a lot of people have identified that 3D modeling is one of those competencies that leads to engagement in some of these careers. And so this funding is coming from this organization to help us think about how can we more broadly expand the 3D model of printed graphics supply through engaging diverse students and working with them to, number one, learn the modeling skills, but for me, more importantly, to be starting to think about how we make our world accessible. So really thinking about how do we design a curriculum to support students in thinking about some of these semiotic questions about information representation, to be thinking about how to make our world designed for all, to be thinking about how to disrupt some of the rhetorics that promote inequality and hate and fear in our world. And as a designer myself, I have found empowerment through learning how to manipulate material and how to have meaningful social engagement while designing. And so this has been kind of taken up as an interesting design task to essentially engage these students in the work that many of us are doing here. And so we've been designing a curriculum based off of the idea of constructionism, again, that you really make sense through hands-on building, the idea of critical making, that our lived experiences with technology can really support us to be thinking in new ways, that we can actually think with technology at the same time. It's because we are beings that live in this material world, and we are very much impacted, and culture is created by the materials that we are living with. We're thinking about universal design for learning, as well as studio-based instruction, meaning that there's freedom to explore with some guided instruction, but also some critique. And so that as designers, we're not afraid to get critique. And in this case, hopefully really bringing people who are blind and visually impaired into the design process, not only as critiquers, but full participatory designers. And so this is an image of one of our first workshops where we are looking at, in this case, we are using the Makey, which is it's like a circuit system that allows you to embed sound into any object in a very embodied way. Essentially, you just connect a circuit and connect the page to that circuit, and you can create a trigger where you push something on the page and your computer will play whatever sound that you want. And so we're looking at how to, again, engage students in this process, but also design with them. So I have probably 1 minute left, and so I'm just gonna do a quick overview of a few of the more technical projects. CraftML, I encourage you guys to go check this out. It's a HTML-based 3D modeling program. So if we have students that are wanting to learn to code, they can come in and have a visual representation, but also we're working really hard. I'm not sure that it's totally accessible yet, but the idea that people who are blind and visually impaired who know how to code in HTML could come in and quickly model in this environment, which is HTML is a simpler computer language than C++, which some of the other OpenSCAD programs are used to model in. we're also looking at how to create through code some really interesting modules that you can put into that can be printed. So in this case, we have a series of gearboxes that are pre-designed that you could just bring as a digital file and place them into an existing 3D model, and then make that model come alive with movement. So this is on Thingiverse right now, and again, I can provide more information. And finally, we're looking at how to develop the technical infrastructure to put textures on curved surfaces. And so that's working with algorithms to identify the geometry of these surfaces. And with that, I'm done. Thank you.
Thank you, Abby. Do we have time for a few questions? Okay. Does anyone have any questions for Abby? Yes.
I can repeat the question if...
We can just repeat the question if you ask it.
How do you plan on sharing the feedback that you're getting from all these various places? And have you published anywhere some of the results and what parents as well as children are doing about this? And if you were in the session this morning, Jen Taz's presentation where he talked about the recognition study that he did comparing several different methodologies of raised line, thermoform, and texture, tactile pictures. Have you thought about contrasting your process with some of those other methodologies and doing recognition studies similar to that?
So there are two parts to this question. One is about how are we distributing the knowledge based off of this research in different forums and back to the participants. And then the second part of the question was about evaluating 3D modeling in relation to other production methods and representations from a perceptual psychology perspective. So to the first point, we have been publishing. We have several publications mainly within the interaction design and the human-centered computing community. T-Access is the accessibility computing group where we are producing some of the kind of more design ethnography findings. Interaction design in children is another group. And then there's the fabrication and learning community. These are all the Academy of Machine Learning group conferences. And again, I'm just now really starting to think more about publishing this work in more of the academic community. And so I have a backlog of work to analyze. I'm actually more of a doer than I like to implement stuff. I'll hopefully have more. And then the second question, so coming to this conference is really informative, right? Because we have these different groups of stakeholders who are interested in this, and I'm actually very interested in who we all are as a community. And so I think the work that I'm particularly doing is actually more sociocultural than it is per se on the perceptual side, and saying that's not my expertise. I'm more interested in how people are designing this material, and so if we can get this material out there, maybe then it can be used to do some of these more rigorous experimental studies. But for now, I'm interested in people's value orientation towards this. Does that address your question?
Great. Thank you.
Great.
Thank you very much, Abby.